Hello students and welcome to a new chapter. Today I will be discussing about chemical bonds. The basis of today's chapter will be only up to class 10th and we'll continue this chapter and we'll go into the class 11th. So today we'll discuss only chemical bonding with respect to class 10th. So let us start. First, before starting we should always know about the chapter and what does it deal with. So the basic of this is chemical bonding and we should know what a bond is. So let us start. What is a bond? It is an attractive force by which two or more elements combine together. You can simply take an example when two human beings or two persons join hands with each other, their hands may be considered as a bond. It is generally an attractive force. Another question is why elements need to make a bond. The science always deals with why and how. So here we know what is a bond, but why does an element needs to make a bond? Every element needs to be stable. Not element, but everyone needs to be stable. For example, if you are standing, you will be more happier if someone offers you a seat, and you will be happiest if someone says you to lay down. Similarly, each and every element wants to be stable, and this can only be achieved by having octet, that is 8 elements in its valence shell, the last shell. So some elements which does not have octet, 8 electrons in its valence shell, form bond either by sharing or by accepting or donation of electrons so that they may become stable. Okay, so there are basically 3 types of bond which we will be discussing today: ionic or electrovalent bond, covalent bond, or coordinate bond. So let us start with ionic bond. It is the bond formed by losing or gaining of electrons. That is, any element loses or gains electron and forms ion, positive and negative ions. And as we know, opposite charges attract each other, and these type of attractive force are known as electrostatic force of attraction, as I have written here. So the bond formed by the elements by losing or gaining electrons, thereby creating electrostatic force of attraction. Here also I have taken one example of sodium chloride, NaCl. The atomic number of sodium is 11 and its configuration will be 2, 8 and 1, whereas chlorine has atomic number 17 and its configuration will be 2, 8 and 7. To achieve octet, sodium must lose this electron, and to achieve octet, chlorine must accept this electron. It will become 8 and this will become 2 and 8. So here I have only shown the valence shell. 1 electron of sodium is shown by cross and 7 electrons of chlorine are shown by dot. Sodium loses this 1 electron and chlorine gains 1 electron. See here, with 7 dots I have shown 1 cross, which means 8 electrons, 1 of sodium. Sodium forms positive charge and chlorine forms negative charge, and the force of attraction is formed between them, which is called electrostatic force of attraction. And finally the compound NaCl is formed. This is what we should know about ionic bond. Ionic bond is also known as electrovalent bond, and the only requirement for it is difference in electronegativity. For electronegativity, you can see the previous video on periodic table. It will explain you what electronegativity basically is. Next is covalent bond. When the electronegativity difference between two elements is not much, so they cannot lose or share electrons, in that case there is sharing of electrons. That is, ions are not formed and electrons are shared between two elements. You might be very much familiar with the concept of sharing. Sharing means when both of them can use the same thing. So let us start with covalent bond. When bond is formed by sharing of electrons is called covalent bond. Generally elements having valence number of electrons 3 or 4. Here I have taken example of CH4. This was the dot structure I showed you for ionic bond, and this is the dot structure for covalent bond. So let us start. Carbon has electronic configuration 2, 4 and hydrogen has 1. 4 electrons of carbon are shown by cross and 4 hydrogens have each one element having 1 electron. Only hydrogen and helium needs duplet, that is 2 electrons in its valence shell to be stable. The rest other needs 8 electron. So each hydrogen shares one electron of carbon and forms duplet, that is 2 electrons, so that it becomes stable. And carbon shares one electron from each hydrogen, in total 4 electrons, and total gains 8 electron and becomes stable. This type of bond is known as covalent bond. Covalent bond are further of two types, polar covalent and non-polar covalent. When the difference in there is difference in electronegativity between the atoms bonded, poles are formed, that is positive and negative charge. This could be directly concept with the strength. For example, if you are playing a game of tug of war, the strongest one pulls the rope towards itself. Similarly, in case of electronegativity also, when one of the element is strong, it pulls the shared pair of electron towards itself. Here I have shown example of water where a positive charge is formed on hydrogen and negative is formed on oxygen. This sign shows partial, that is only for some amount of time and is very weak. It is not similar to ions. It is generally formed in case of heteroatoms. Next is non-polar covalent compound. When the atoms are same, that is the difference in electronegativity is very less, then no poles are formed and it is known as non-polar covalent compound. Example H2. Next is lone pair of electrons. This question has been asked many times in your board exams, so you can write this. Those electrons which don't take part in bonding are known as lone pair of electrons. I will show you this, a lone pair, in form of example. Here I have taken example of water again. Oxygen contains 6 valence electrons and hydrogen contains 1 each. So see, 6 electrons of oxygen are shown by cross, 1, 2, 3, 4, 5, 6, and 2 hydrogen electrons. Hydrogen, as I told you already in covalent bond, that it has to complete its duplet. So both of them take 1 electron each from the oxygen and complete its duplet, while oxygen takes 1 electron each from hydrogen and complete its octet. But there are 4 electrons, 1, 2, 3 and 4, the one which are underlined. These 4 makes 2 pairs and these 2 pairs do not take part in bonding. In bonding only these 2 electrons have taken part. So these non-bonding pair of electrons, they do not take in bonding and hence are known as lone pair of electrons. Memorize this with the examples because this is asked. And last one is coordinate bond. Sometimes during the bond formation, one element without any electron comes towards the compound, and the bond formed, and during the bond formation the electron is only donated by one element. Like we already discussed, in oxygen there are 2 lone pairs, and we know about H3O plus, hydronium ion. In this case we have seen that oxygen has 2 lone pairs and one H plus comes. H plus means hydrogen which has 1 electron loses this electron and forms H plus, that is with no electron. When this comes, it shares both the electrons of oxygen only, these 2 electrons, and bond is formed, that is both of the elements take part in bond formation but electron is donated by only one. This type of bond is known as coordinate bond. An example is H3O plus and NH4 plus, hydronium ion and ammonium ion. So this was the chapter only for chemical bonding. Nothing else will be asked in your boards, and I have given you 2 questions to solve. I will give you more. Solve it, and if you have any problem, comment below. So I have given you examples. You have to draw the dot structure of NH4 plus ammonium, aluminum oxide Al2O3, calcium oxide CaO, and MgCl2. So all the best. Keep watching and keep studying. Stay safe. Subscribe to the channel and share with your friends. Thank you.